5.2, we're solving systems by graphing. Let's do a quick reminder of what a system is and kind of what are these solutions that we're trying to find. If you'll remember, there's three possibilities, right? Either we have two lines that intersect and we get one solution, or they don't intersect at all and we get no solutions, or possibly they're overlapping each other, they're on top of each other, they're identical lines, in which case they share all their points and we say infinite solutions. All right, so let's go ahead and let's look at these examples here. I'm going to start with problem number 1. Now it says we're going to solve today by graphing, which makes sense, right? If we get y equals negative x plus 8, we get y equals 3 over 2x minus 7. It's perfectly set up here to graph. So we're going to start with a line at positive 8, okay? And we're going to go down 1, right 1, right? Our slope is 1. And go ahead and plot your line. Now you do want to be as exact as possible when you're drawing these lines, because if you don't, then you're not going to be able to see the solution if you're just kind of sketching here. Sketching is not going to work. You really have to plot points and line up your straight edge. Second line, we're starting down here at negative 7. My slope is 3 over 2, so we're going up 3, right 2. So here would be my next line. And we can clearly see the solution. Right, we can clearly see the solution is going to be here where they cross. Okay, so my solution is that point where they cross. So that point is 6, 2. This is my answer. Okay, that's my solution. Now, we definitely always want to be efficient and we want to work smart. I could also just type these in my calculator. If I go to y equals, I can type in negative x plus 8, and I can type in 3 divided by 2, or 3 halves, or you can use alpha y equals 3 halves x minus 7, and I can graph it in my calculator. Let's take a look. All right, yeah, I can see that looks pretty similar to what I graphed. I would really get in the habit also of going to your table. So second graph's going to take me to my table. Can we see that when x is 2, both of my y's are, when x is 6, both of my y's are 2's? That's how we would recognize the answer in our table. So we definitely would always want to check just to be sure. All right, let's go ahead. Let's look at problem number 2 here. Problem number 2, we have to take a few extra steps because right now we don't have y equals, and we want y equals if we're going to be graphing. So let's get y equals. All right, so my first line, which I'm doing in red, I'm going to say 5x plus y equals negative 2. I really just have to get the 5x to the other side because I have y equals now. So I got negative 2 minus 5x. All right, this is the one I'm graphing. Let's see here. I'm going to start with a negative 2 because that is my y-intercept. And my slope is negative 5, so we're going down 5, right 1. Okay, so here is my line. Let's see here. Let's see, 1, 2, 3, 4, there we go. Okay, there's my line. And now let's do our second one. Let's see. We started with 2x minus y equals negative 5. Got to get rid of that 2x, so minus 2x on both. We got negative y equals negative 5 minus 2x. You cannot leave this negative on the y. So I'm going to divide everything by negative 1. So I've got y equals negative, negative. I got a positive 5, and then a negative divided by negative is a positive 2x. All right, so here's my second equation. So put a dot at 5 for my y-intercepts, and my slope is a positive 2. So here is my new line. All right, and again, I think we can probably see the solution pretty clearly. We've got it right here. And that point is negative 1, 3. All right, and that would be my solution. The point where they cross is my solution. All right. The next two we're going to look at are a little bit different. The third one requires us to do a little bit more work. So let's look at number 3. All right. So we're going to take number 3 and we're going to get y by itself, right? Because that's definitely going to make our life easier if we're trying to graph. especially because the intercepts on this one wouldn't be very good. All right, so I'm going to do 7x. I got negative 4y equals negative 8 minus 7x. Let's get rid of the negative 4 using division. And now I've got y equals positive 2, and then negative 7 divided by a negative 4 will give me a decimal that I don't like. I'm going to leave it as 7/4 x. Now it is positive. There's my line. Okay, so positive 2 up 7 over 4 puts it right here. Let's draw my line. And let's see here. Down 5 over 4. Okay. So that's one of my lines. Now let's do my next one. Again, I have to get y by itself. All right, we got x plus 2y equals negative 14. Right, I'm working with this one now. I'm going to get rid of the x. So now I've got 2y equals negative 14 minus x. Divide by 2. And I end up with y equals negative 7 minus 1/2 x. All right, so negative 7. Down 1, right 2. Down 1, right 2. So here is my next line. And my solution is right here. All right, that point is negative 4, negative 5. All right, that would be my answer to this one. And again, let me just show you one more time how we can check in the calculator. So I'm going to put my two equations in the calculator. My red equation was 2 plus, I'll do alpha y equals for the 7/4. All right, 7 on top, 4 on the bottom. So we got y equals 7/4 x. And then the next one we've got a negative 7 minus 1/2 x. So minus 1/2 x. And I will look at my graph just to kind of get a good sense of what's happening here. So let's take a look. All right, looks like I graphed it pretty well. Okay, negative 4, negative 5. Let's check the table just to be sure. So second graph, we're looking for when x is negative 4. There we go, right? When x is negative 4, my y's are matching at negative 5. So negative 4, negative 5 is my answer. All right, last but not least, final example here. Problem number 4. This one is a little bit better because at least one of our lines has y equals to start. So I'm going to graph this first one. And I've got negative 3 plus 8. So 8's my y-intercept. We're going to go down 3 over 1. And we're going to graph this. Okay. And now my other equation I do have to work with a little bit to get y by itself. Let's get our x's on the right side. So now I've got 2y equals negative 10 minus 6x. Finally, divide by 2. And I've got y equals negative 5 minus 3x. All right, so this time my y-intercept is at negative 5. And my slope is at negative 3. Okay, draw your line. And okay, now wait a second. What do we notice about these two lines? These lines are parallel, right? And we actually probably should have, at least we could have recognized that they were parallel before we even graphed them, because my equations have the same slope, right? They're different equations, but they do have the same slope, which means that the lines are parallel. So they're never going to cross, right? They're never going to cross. They're parallel. So I'm going to say my answer to this problem would be no solution. The lines will never cross. Okay? All right, so as we learn different ways to solve, my best piece of advice would be that if you are given two equations that start with y equals, graphing is going to be the best bet. And in fact, if you're given them in any other form, you can always transform the equations to get y equals and find your answer by graphing, right? The solution to a system is a point, xy, where the lines intersect.